Hello and welcome to Modern Analytics on Cloud Native Architecture with Fast S3 Storage. Today's webinar is sponsored by Pure Storage and Intel and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of this presentation where we'll discuss in greater detail some of the top questions that you have. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, and slide advancement issues, but if that doesn't work, just let us know in the Q&A and we will provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a PDF there for improving Splunk and Kafka platforms with cloud-native technologies. Also in there are links to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Event Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. So with that, let's get to today's fantastic content. It is my pleasure to introduce you to our presenters today. We have Jan Oftenkamp, who's Director of Solutions, Analytics, and AI and ML at Pure Storage. We have Merritt Stitston, who's Enterprise Data Center Cloud Solutions Architect for Intel. And we have Somu Rajathurnam, Technical Director at Pure Storage. So I'm going to turn things over to Jan to get us started.
Thanks, ATM, for giving us the opportunity to present to this audience today. And I'd like to take this same opportunity to welcome everyone. We're thrilled that you are able to join us today to talk about modern analytics on cloud native architecture with Fast S3 Storage. This presentation is delivered today by both Pure Storage and Intel. Before we jump in, we'll make some quick introductions and then we'll go ahead and get started. So I am Jan Oftenkamp. I'm the Director of Analytics and AI Solutions with Pure. And Somu, I would ask you to introduce yourself.
Sure. Hi, I am Somu Rajaratnam, Technical Director at the Solution Engineering team at Pure, focused on analytics and database solutions.
And I am Merritt Stitston. I'm an Enterprise Cloud Solutions Architect at Intel. Thank you for having me.
Thanks, all. So let's go ahead and get started. At Pure, we focus on helping customers achieve their business goals and delivering positive outcomes. And so when we talk with many of our customers and we ask them how things are going with their analytics deployments, they often share with us the challenges that they have in this space. Many find it difficult to meet the demands of the business with ever-increasing data volumes and a desire for faster insights. Inconsistent search is often brought about by a requirement to store tier storage or software options to reduce the capacity, both of which tend to affect the performance, and time to insight matters. When you think about cost, how can you control cost when you have to add compute, when you have the need to add storage? This oftentimes the case due to the number of copies of data that is required in this legacy solution. And as these clusters scale, customers tell us that the time required to manage these is increasingly problematic. Rolling upgrades are done that can take weeks as you're moving data off and back into the cluster. And we also hear customers talk about the challenge from node or server failure, where data has to be validated or reconstructed to return to the cluster. As analytics becomes more and more critical to the business, what was once acceptable is no longer the case. As a part of today's prezo, we're going to share with you today some testing that Pure did with Intel. What you see here are those challenges that were identified by Intel around their Splunk deployment. Some the same as we've already covered, but there are other ones as well. When you add compute with storage, when you add compute with storage, your utilization oftentimes is on the low side. We talked about some of the overhead in managing the clusters. And what about compliance requirements to retain data longer? In a similar session we did just a few months ago, we actually polled the audience and we asked them to share with us what their top issue is. And we asked them to identify this between scale, cost, operational challenges, or performance. And what we found is that cost and operational challenges were number 1 and 2, with 31 and 30% of the audience responding. But scale and performance a close second behind those. So it validates all the things that customers are sharing with us. And I'm sure these are things that you are challenged with as well. The bottom line really is that these analytic platforms are based on an architecture that is out of date. Analytics providers in the last few years have recognized this challenge and developed architectures for a cloud-based offering built around S3 with disaggregated compute. This offering can be deployed in the cloud or it can be deployed on-prem, and it benefits all. When you are able to scale compute separate from storage, you're no longer overspending on unnecessary resources, and you can scale on demand. Because the storage element of this takes over some of the data services, your storage requirements are reduced. And with the implementation of some of these offerings, the software updates are much more simple and automated. And because we are doing things from a storage perspective, we can offer you higher availability with these automated software updates. If you look on the right, these are some of the partners that Pure is currently partnering with. And these are some of the partners that really led the way in this approach. Splunk, Confluent, and with Confluent, it's Confluent tiered storage for Kafka, Elastic, and Vertica. Our most recent partner ad is with Snowflake. And many of you might remember that we issued a press release back in May that talked about our partnership. And the idea is that we would bring Snowflake compute to data where it lives. We expect that we're going to go into public preview here very soon. We're going to focus on Splunk for much of our presentation today, but it's important to remember that these challenges are not unique to Splunk, and that a lot of the applications or the different use cases that are part of your data pipeline are subject to the same challenges. But why on-prem? Well, not every customer can deploy in the cloud. Oftentimes, there are some concerns around performance. Data sovereignty may be a requirement, and there are compliance issues. But many customers, even when they deploy on-prem, still want that cloud-like experience, one that is cost-effective, simple to manage, resilient, and elastic at scale. We already said that the storage layer takes on some of the data services provided by the compute layer in the past, and replicas are no longer required for the majority of the data stored. Combine this with data reduction capabilities such as compression, and you can begin to see the economics gained with this approach. To accomplish this, we have put what we call a recipe together to deliver the performance needed with S3-based architecture. Modern S3 solutions like Pure's FlashBlade can drive tens to hundreds of gigabytes per second. So when searches are performed at this layer, speed matters. And because the network is the vehicle by which all data is ingested, stored, and searched, focus on the capabilities here are equally important. 10 gig is the minimum required, but many customers benefit from and are already deployed on 25 or 40, with some planning for 100. And lastly, you want to ensure that you're maximizing application performance. That goes hand in hand with high performance storage. And the key to this is leveraging containers or virtual machines, not only delivering high performance, but also operational benefits. In a moment, I'll expand on the container model. But before that, the net of this is that you want to architect this from end to end to ensure that you have no bottlenecks in the solution. We put together a simple diagram to capture the container concept. We'll focus on Kubernetes because it's newer, it's what folks are talking about, but the same benefits really apply to virtual machines. When you go from bare metal to containers, you often see significant gains in performance and in software management. With a bare metal deployment, you're not only managing hardware, but also the software that runs on top of it. Go back to the challenges at scale, patching, for example. You're also limited to a single instance per with some number of threads. But when you look at the diagram on the right side of the slide, you can see that when we containerize these, that you multiply these instances by a significant number, increasing the number of threads. And you can begin to understand how we deliver the performance mentioned. Let's play this forward around software maintenance or updates. You can orchestrate the deprovisioning of a current node where a new image is deployed and connects to the S3 storage, downloads the metadata, and starts to participate in the cluster. The end result of which is you have a more performant and simple to manage solution, particularly at scale. And with this, I'm going to hand it over to Merritt, who will talk about some of what was done when we jointly tested Intel's Smart Store deployment.
Thank you, Jan. So one of the things that we did was we started off with the concept of saying we want to take and create this containerized solution using not only Splunk, but also using Kafka so that it would be a pipeline or event streaming application, which most environments use. And then also access the disaggregated storage, which again is another thing that a lot of customers are looking at, as Janet said. So with Pure Storage architects and Intel architects, we built this Kubernetes test environment. We deployed it on disaggregated storage. And that's important because Smart Store requires an S3 compliant storage array on the back end, which the Pure Storage array is, or the FlashBlade. And then lastly, and this is super important, we worked with our Intel team to have production data used for all of our testing. So again, we used our Confluent Kafka environment, took that environment, ran data through it, captured 8 hours of data that was live production data so that we could replay that data over and over again. So what did that mean? So what we were able to do is hit a peak ingest rate of 886 megabytes per second with 400 successful searches per minute. So later on, you're going to hear a little bit more about that, where you would be able to see what it would be per day. But these are astounding numbers. And as we go through the rest of this presentation, you will realize that as well. Next slide. So what did that mean from an ingest perspective? So we went from bare metal to a containerized environment. So our ingest rate from bare metal to containerized increased by 3x. Our search performance, that's the number of successful searches from bare metal to a containerized environment, increased by 4x. And our CPU utilization went up from bare metal up by 5x. So those are the kind of things that changing this architecture and using disaggregated storage, containerization, and Intel can do for your environment. Go ahead and go to the next slide. So what did that environment look like? So on the left, you see where we used Intel's production data. So this is all of our SIM data, or security information and event management data. So it's the same things that we would ingest and do our monitoring in our environment. The data collectors pushed it over. We ran brokers, our Splunk indexers and search heads all on the same boxes in the containerized environment. And then we use their connectors to connect back to the pure FlashBlade that is, as I mentioned before, S3 compliant. On the bottom, those are the exact same 9 servers. So there was no change at all. No configurations, no bio changes, no hardware changes, no networking changes, nothing. They were the exact same 9 physical servers that were used for the Kubernetes clusters as our bare metal testing. Next slide. So when you look at what it was that we did and putting this environment together, you could recreate this on your own. So these are the components. On the left, you see our component software. We've called all those out. Since this was completed, Splunk has issued a new Kubernetes operator. So that would be something I would recommend. On the right-hand side, you see the components from the FlashBlades by Pure Storage, and then below the components that were provided by Intel. Now, one of the things I'll tell you is that you would look at this and say, wow, you're using a very high-end processor. Well, yes, we are, because you're going to increase the density on that physical server, and you will see from some of the testing numbers exactly what happens. Remember, we went up 5x on CPU utilization. So if you go with a lower end SKU, you're going to starve your processing for compute power. Another thing that's really important is that you really need to consider your NIC cards. So as Jan had said, our customers now in these type of environments are looking at 25 and 40 gig for dual port NICs on their host servers. This is, again, really important because you are driving tremendous amount of throughput on these platforms, and you don't want to spend money on having a really good back-end storage array and then having a good processor, but then starving your ability to push that data out either from server to server or into your storage array. So really pay close attention to what you're doing on that environment. Next slide. So this slide outlines what we had done and how we connected the servers. So on the left side, you see all of the Intel processors. The black lines connecting the Arista switches are all 25 gigabit NIC cards connecting into that. And each server has 2 so that we have failovers to both of the Arista switches. And then the purple lines that you see, the MLAG, and then from the Arista switches to the FlashBlades, those are 100 gigabit connections. So you can see that we're really driving tremendous amount of throughput on this platform. So again, this is something really important to pay attention to. Your networking is going to be one of the most important things you're going to have to do on this environment. Next slide. So when you look at the environment, what you have here is this is what we did on scaling. So the blue bars down on the bottom that show bare metal, we had 9 servers. There was 1 search head, 3 brokers, 5 indexers. Once we containerized it, that jumped from 9 instances to 62 instances of Splunk and Kafka. So then we had 9 search heads, 18 brokers, and 35 indexers. So real big change on that side. These are exactly the same 9 servers that we used for our bare metal testing in blue, and then to the purple ones on that side. The key components were the Splunk operator for Kubernetes and the Confluent connector for Kubernetes. So this is really the power of being able to use your disaggregated storage and containerization with your Intel processors and NICs. Next slide. So this one's to you.
Yeah, thank you very much, Merit. So following up on the testing that we did with Intel, so this is one of the major testing, the test results, which was actually summarized by Merit earlier. So as you see here, we actually did ingest and search testing with Splunk. So as you pointed out, we actually ran the test for 8 hours. So we initially did with the baseline on the physical servers, and then similarly with same exact setup then on Kubernetes, then we actually ran the test again, right? So when we go back to the physical servers, with 9 servers, as you pointed out, with 1 search head and 5 indexes and 3 brokers, we were able to ingest close to 301 megabytes per second of Splunk data. And at the same time, we were actually scheduled searches, dense searches. So it was concurrent searches that we scheduled, and we were able to do 90 searches per minute successfully for that particular setup. And during this time, when we measured the performance metrics from the CPU side of it, it was bare metal was around 12% utilized across the board. Then we repurposed the same exact 9 servers, and then we deployed Kubernetes, and then we actually scaled up the number of instances for all these applications. As we saw in the earlier slide, we went up all the way to 35 indexes and 9 searches. And then we repeated the test, and as you see here, we are able to get to 886 megabytes per second of Splunk ingest, which is sustained rate. We even saw close to 1 gigabyte at some point, but sustained rate of 886 megabytes, which basically equates to almost 73 terabytes of data that you will be able to ingest in a day, if you think about from a daily ingest rate. And at the same time, we were able to increase the number of searches, the successful searches that could run in a minute, all the way up to 400. One aspect of it with respect to searches here is when you're doing with physical server or with bare metal, not all of the searches were hitting just the cache. So we made sure, like almost in the case of physical server, 1/3 of the data was hitting, or 2/3 of the data was hitting on the cache, and 1/3 was going back to the S3 to pull the data back. Similarly, in the case of with Kubernetes, almost 70% or 3/4 was actually hitting the cache, and 1/4 was actually pulling the data from the S3. So this is not just hitting the cache all along. We are ingesting data as well as doing concurrent searches, and data being pulled back from S3 as well as being ingested into S3 to support the ingest, right? So both ingest and search are all happening within the 8-hour time window. And also, the biggest thing that you see from the table there, the average search time, in bare metal, these searches, which we are scheduled to run, which are almost 90 searches per minute, each one of them took almost 22 seconds to run. But then when it was run on Kubernetes, they reduced it to 16 seconds because we have more instances of the indexes available. And so you have a lot more connection that can actually be initiated from these indexes. And as you can see here, the utilization with on the Kubernetes, it went up to close to 58%. So as Merit pointed out, it's almost 5x improvement that we saw. The reason we didn't actually increase much further, we could have actually gone up from 35 indexes probably to 40, 45 indexes, but we actually wanted to limit the utilization. We didn't want to go all the way up to 90%, 95% utilization. We're just trying to see the scaling. But at least you can see from this test, when we actually get containerized and using the same exact servers, we're able to increase the ingest, the search, as well as the utilization across the board. Next slide, please. And so that was on the compute side of it, right? So the compute plus high performance S3. So the next search, the test that we did was specifically to do what is called as predominantly historical searches which can actually make a break in a lot of cases, because there are reasons why you might want to do this. Even though most of the searches will be happening from the cache, there are cases in case of any failure scenarios that you want to check with respect to the security aspects. Then you might want to go back and pull the data. If it's not in the cache, then you need to be able to pull the data back from the cache, from the S3. In this particular case, we did a super sparse search, which is like a IO bound search, which is like a needle in a haystack kind of search. So to simulate this, what we did, we actually evicted the cache across the board and issued a search. And as you can see here, it has to pull back almost 376 gigabyte worth of data from S3 back to the cache. And once it is in the cache, then it actually searches and then comes back. This particular search brings back almost 64 events out of multi-billion events that was available. As you can see here, it took almost like 84 seconds to bring back those 376 gig and to get the results as well, end to end. And throughout this time, like the average download throughput was around 4.4 gigabytes per second, but we did see spike up to 19 gigabytes as well. So if you think about it, this is actually huge amount of throughput that we are dealing with at this point. Had this been in like kind of like a cheap and deep kind of S3, it would have taken minutes or hours to get the same exact data, right? So speed actually matters as well. And that's exactly what we wanted to showcase with this particular test scenario. Next slide. So we also wanted to test similar one on Confluent Kafka as well. Like all the tests you saw earlier was on Splunk, but we performed similar one on Kafka. As Med pointed out, Intel is using Kafka, where they actually pull all the data from their Intel production system, comes through Kafka, and through the connectors, they actually gets ingested into Splunk. So as you can see, there are requirements. I think one of the challenges that Jan pointed earlier, there are compliance requirements, and if they want to retain data for a longer period of time, you can't keep the data in local storage for a longer period of time, because the amount of replica copies and then retaining it for a longer period of time makes it so cost prohibitive to keep them on the local storage. So Confluent Kafka actually has a functionality called tiered storage. So what we did, we actually tested this functionality with local storage first, and then repeated the test on Confluent tiered storage. So we were actually, the data was actually all retained in local storage first, and then through the connector, we were consuming data from Kafka, and we ingested into Splunk. As you can see here in the graph, the left side, it shows the ingest ratio or ingest rate when it's read from Kafka local storage. And then we repeat the test by having the data on S3, like Confluent tiered storage. So when you're consuming data from Kafka into Splunk, it is predominantly pulling the data from S3 through Kafka tiered storage and then ingesting into Splunk. And as you can see here, the performance difference is not much. It's almost similar. So what it means is you can retain data for a longer period of time for Kafka in a tiered storage. And if you have to even access the data, you're not impacted by the performance at all. So it gives you best of both worlds. Retain the data for longer, but without sacrificing performance. So we were able to validate this on the Kafka front, and you saw earlier on the Splunk front as well. Next slide. Back to you, Jan.
Thank you, Samu, and thank you both for sharing with this audience what it was, number one, that we were testing, and number two, the impressive results that we were able to achieve. So some of you may know what Pure's FlashBlade is, and some of you may not. For those that don't, Pure introduced this platform just over 6 years ago. This targeted at unstructured data sets. This platform was one that was designed and built for these very type of workloads. It's one that delivers performance and simplicity at scale across different workloads while providing critical data services to all applications. We expand this and leverage our evergreen offering to ensure that the architecture that you deploy today will carry you forward into the future, while leading the way around power consumption that is part of a recent report and documented and captured out on purestorage.com. But here's the really good news. The platform that we tested on and the one where we were able to capture these incredible results was our older platform, our first generation. FlashBlade S was introduced earlier this year in the June timeframe, and it's our second generation FlashBlade. So all the goodness that was delivered in our first offering only gets better. You can count on even more performance and data reduction via compression. So let me revisit some of this and summarize the solution that we have been talking about. We talked about leveraging the cloud-like capabilities provided by these application providers. We focused on Splunk and their Smart Store offering. We expand this offering with FlashBlade, and it is further enhanced with containers. When you think about Smart Store and what that brings to the table, it's disaggregating compute from storage. It means that you spend money on only those resources that are actually needed instead of both. This introduced fast recovery from indexer failure and reduced the storage requirement as we're leveraging the data services in the storage platform for high availability. I said it was expanded with FlashBlade because FlashBlade delivers this performance and simplicity at scale that I already mentioned. It allows you the opportunity to do seamless upgrades, again, lending itself to a higher level of availability. And we also have an optional OpEx model where you pay for what you use. When we talk about enhancing this with containers, we want to deliver that same level of agility that you get in the cloud at the compute layer. And we want to make sure that we're optimizing server utilization that we talked about as part of the testing done. And we also want to make sure that we're maximizing performance. So all of these things come together to deliver this experience on-prem. As we look to finish this today, I want to ask you to remember a few key things. Pure is bringing you a cloud-like experience to analytic applications on-prem. This enables you to meet the business demands, take on more data with relatively consistent time to insight. We want to share with you improved operational efficiency and TCO, accomplished with ease of management, improved efficiency around node failures. And this means that there's less time managing and more time spent extracting value for the business. Increased infrastructure utilization and app performance. Merritt shared with you how we were able to accomplish that by deploying containers, which also lends itself to optimized total cost of ownership, along with providing predictable performance at scale. I'm going to close out today by sharing with you some of the resources that are available. This work done with Pure and Intel is captured in a paper that is available on Intel's site as well as Pure's. But we're going to be emailing everybody that's participating today copies of these. There's a high performance data analytics with Splunk on Intel hardware paper that is available from Intel, and a couple of other papers from Splunk that focus on Kafka, on Kubernetes, and Splunk Smart Store on FlashBlade. So I'll take this last opportunity to thank you for participating today, and we'll look to move into the Q&A portion of this session.
All right, great presentation. Lots of really good information in there. Jan and Merritt, are you guys ready for some questions?
Yep, sure am.
Okay,
I am.
Great. So The first question here comes from Charles, who's asking, so is the Splunk that you're speaking of different from the Splunk that provided SIM?
No, it was not. So if
Okay,
with Splunk, you can run different applications on top of it. So we used the Splunk Enterprise and then the Splunk Enterprise Security.
gotcha. All right, excellent. Thank you. Thanks for that clarification. And Charles, thanks for the question. Next one, they're asking, does Pure Storage support multi-site Splunk deployment? So another Splunk related question. Jan, what do you think about that one?
We absolutely do. That was functionality that we were able to introduce earlier this year. And we have several customers already that have adopted that.
Okay, super. This next question looks like one for you, Merritt. Will your architecture work with other Kubernetes platforms?
Yes, as a matter of fact, it is not bound by any Kubernetes provider. So if you want to use OpenShift or Rancher, we in this case use the open source version of Kubernetes. So whichever one you're currently using, you can continue to use that. Also, if you're going to move to the cloud and you want to run your own instances, it would work with any one of the cloud instances of Kubernetes as well.
Okay. All right, great. We've got a comment from Kartik saying it's a great session. So thanks for that feedback, Kartik. And anybody who's got a question, please enter those in. We've got plenty of time for some questions here. Some more here. This one is for Jan. Does Pure's consumption-based subscription model support Splunk?
It absolutely supports this solution. And we frankly have many customers that choose this option. And for those of you that are not familiar with our consumption base, this is kind of a pay-as-you-go model. It's oftentimes the choice of customers that are deploying this because with the rapid growth here, it is extremely difficult to forecast your needs ahead of time. And this affords you the flexibility, again, like I said earlier, to pay as you go.
All right. Yeah, so you're talking about pay as you go there. We actually had a question here from Deb who says, she likes the model for paying for what you use. Is there a minimum amount of storage you have to purchase to begin? And so how do those programs work?
Yeah, I would actually ask that teams or folks that are interested in this reach out to Pure Storage. We can identify the sales team that would support that. There is a minimum, but it's a small number. And I don't have those numbers right off the top of my head. Apologies. But please reach out. We'll get that information to you.
Excellent. Okay. Next question for Merritt. Did you test for the failover when a container or a node fails?
No, we did not. So as you can imagine, Intel has to test lots of applications from lots of vendors. So in this case, we just built it as a standalone production environment. So we made sure we met all the requirements for it to be a production workload, but we did not set it up to be high availability or to fail over across multiple sites. We'd have liked to have done that, but the testing just would have been too long and too complicated actually to have architected that. And as I said, we have a lot of other applications that I work with that we have to run through testing. So that was just a limitation of this test. So we just stuck with a production environment and just tested that only without those other capabilities.
Okay. Yeah, lots of questions here about the testing and the examples. This next one is, why does disaggregated object storage matter in your example?
Jen, I guess it's going to be between you and I, but disaggregated storage is just your external storage array. Now, when you set this environment up, when you use the Splunk operator for Kubernetes, it's a requirement that you use Smart Store. And Smart Store uses disaggregated storage. It has to be an S3 compliant. storage array on that side. So that is one of those requirements. Now, it is actually very good because we can demonstrate that you are nearly the same speed pulling back any of that data if you have to run a sparse search or something else, or you want to run any additional ad hoc reports, that you can reach back into that S3 array and pull that information back very, very quickly, nearly at the cached on server speed.
Thanks for that, Merritt. I'll chime in and just take this opportunity to revisit the concept. The idea of disaggregated compute and storage means that you can also scale each independently from the other. We talked about some of the challenges associated with a more traditional deployment on a distributed model, where if you need capacity, you're also adding compute and vice versa. And this allows you to expand in only the relative area where that's needed. And Merritt, great call out on the performance, especially the performance we saw as part of this proof of concept.
Yeah, I'd like to add on to Jan's comment there too. So that it happens to also be one of the biggest issues that we have at Intel, is that, as we're scaling out these environments, when we run out of storage, even if we have compute capacity, as our testing showed, running at 12%, you're leaving 88% of your performance on the table that you paid for that. So why not disaggregate them and manage them as separate entities and get the maximum performance out of both?
All right, super. Yeah, and there's another question here, and apologies if the disaggregated object storage answers it, but the question here is, what type of data did you use for testing?
We use production data that we were also ingesting through our SIM. So that would have been any of the server logs, NetFlow logs, our firewall logs. So this was all security information that is collected in a normal environment for security information and event management. There was nothing. We took a live feed from what our internal team uses every day to protect Intel's environment.
Okay, excellent. Thank you. Next one comes from Kartik. There's been a lot of talk about S3. Are there other options for storage available, or is everything optimized for S3?
Could you repeat that? Sure. Yeah, I didn't understand the question either.
Okay, well, so we'll get you all the questions afterwards and be able to respond directly. So maybe that'd be the best way to go there. Let's see. Other than that, I think we've run through most of the audience questions here. So, Jan, if somebody wants to get started with Pure Storage and Intel here, or find out more, what do you recommend? What's a good next step?
Well, first off, I'd say reach out to your Pure Storage person, sales representative. Intel doesn't sell directly to our customers, so Pure would be the best place to go to start this conversation, and they can engage us as necessary. Jan, go ahead.
Yeah, I was just going to chime in and say everything that we described today around the proof of concept is captured in the paper you saw. It's available on Pure's website. It's also available on Intel's website. And I would strongly encourage folks to take a look at that. It goes into some additional detail around what we did. And so we also have mechanisms to connect you with teams so they could answer any questions that you have. Scott, if we have time, the question that was asked earlier by Deb about the minimum for the pay-as-you-go model, I was able to quickly get a response around the minimum there, if I could revisit that.
Please do.
Yeah, and so, again, thank you for the question. And 75 TB is the minimum entry point.
Okay. All right, great. Well, thank you. Jan and Merritt, thank you for all these insights in the Q&A, and also to you and Somu for the presentations as well. Very very informative, very insightful. Really appreciate you bringing us up to speed on Pure Storage and Intel here.
Yeah, thank you, and we
and thanks
appreciate.
to everybody attending.
Yeah, thank you for taking time out of your day to participate with us.
And before we wrap up, we do have one more piece of business. It's the Amazon gift card prize drawing. And the winner of that $300 Amazon gift card today is Daniel Yaklich from Pennsylvania. So congratulations to Daniel. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Pure Storage and Intel for making this event possible. And thanks as always for attending and for all of your great questions. That concludes today's event. Have a great rest of your day.